look at some of those equations where they ask you to solve it and try to make a connection for you. Shane, would you read the first one out for me?
Yep, it is log sub 5.
Okay, hang on now, log base 5,
Log base 5 of x plus 6.
x plus 6, okay,
Plus log base 5 of x plus 2
x plus 2,
is equal to 1.
1. Now we're turning these things into equations. But I'm still trying to use properties. By the way, before I jump into it, the way she's presented this to me, which property of the three might I have to apply to this problem to get a start? Looks like a maybe product. I see a plus sign. You're adding logs. Now, before I jump into it, let me give you a little reminder. Since I'm talking about logs, there's a restriction on the x. That's domain. That means there's a restriction on this. There's a restriction on this. Okay, the restriction is that this, all this right here must represent a positive. I cannot do a log on a negative, nor can I do a log on 0. That says x plus 6 must be that, which implies that. Let's point that out before I jump into the solving. The next one has the second term. Yes, x plus 2 also must be this, or it makes no sense. X is greater than negative 2. Now, Alexandra, the reason I did that, that's like my domain. Those are the x's I can use. If I solve this thing, and I get an x that will not satisfy these conditions, I must reject those answers. So the answers I get, when I finally get the answers, I have to go back and say, is that answer that? And is the answer that? If not, it's got to satisfy both. We'll be able to accept it. Now though, to solve this, actually solve it and find x, what x is, yes, I'm going to apply the product property and rewrite this as log base 5. And guys, the product looks like this. First, I want to make sure you guys will agree. Let's rewrote the left-hand side as a product property. Now step 2 is where you might slow down. I'm making all this connect for you. Can anyone be wise and tell me, I think I did it way down here on the end, like in a definition, and I erased that. Can anyone tell me what might be wise now to do, because I got to solve for x. Don't be clever. Oh, I see a couple of hands going up. Yes?
Rewrite 1 is log base 5 of 5.
I heard you say the word log. I don't want to use the word log. Let me give you a little hint. Can anyone tell me, based on all that beautiful work we did before the break, can anyone tell me what this looks like in exponential form? Or tell me by definition, I erased it on the end of the board. What's the definition of a logarithm? And I give it to you down there that I can apply here. I see a hand going up. Shane.
Would it be 5 to the power of 1 is equal to x plus 6 times x plus 2?
There's a mathematician.
That's what it means. Now the word log's gone. That's what it means. That's what we're talking about way down here on the end of the board before the break. Log's gone. By the way, guys, you agree with Shane first. Did she translate that correctly for me? Yes. I don't have a log in there now. I have now a middle school problem. That middle school problem is this. 5 to the first, of course, is 5. The other side, if I should expand this out, guys, is x squared plus, help me out, 8x, is it? Plus 12. You're middle school now. This is a quadratic. Of course, you want to move that 5 over by subtracting and write that quadratic as this. I think 12 subtract 5 is 7, is it? And I now think this might factor. Oh my goodness, we took a pre-calc problem, made it middle school. And then split these up I'm looking for answers of, to consider, to be those two. Is that true, guys? I see some looks like, whoa. Now, can I accept them? Negative 7. Is negative 7 greater than negative 6? No. On the number line, is negative 7 greater than negative 6? No. Gone. Negative 1. Is negative 1 greater than negative 6 like it should be? And is also negative 1 greater than negative 2? The only answer after all that work, I'll place up here, is negative 1. You're finished. Now, you'll say, Professor, I see what you did. You put restrictions on this based on something we did before the break. But negative 7, if you took negative 7 back to the original that she read to me, this is the original in the blue. If you put a negative 7 right here, you've got negative 7 plus 6. That's a negative 1. You're trying to take the log of a negative, which is impossible. You can't take the log of a negative, or 0. Shane, tell me what the next one may look like in trying to solve.
You have log base 4.
Okay, hang on a second. Log base 4?
Mm-hmm.
Okay.
Of x squared minus 9
Oh, nice.
minus log base 4 of x plus 3
X plus 3.
is equal to 3.
Now this is cute. I gotta solve it. Now me, to bring lessons together, let's see what the domain is first. So when I finally get the answers, if they do not fit inside that domain, I have to reject them. Now guys, the first one says this. This, by definition, must be that. This, for a log, must be that. We've done a lot of work tonight. So I'm hoping all these lessons are connected for us. Now, can anyone tell me how can I solve and find the particular x's I need here? So when I finally do get the answers, we don't have the answers to this equation yet. When I finally get the answers, I can sort of check by looking back here. I gotta solve this inequality. Someone tell me a nice way to solve that inequality from way back day 1 when I first met you.
Add 9 to both sides.
Do it again.
Add 9 to both sides.
I could add 9. I'm a little scared there because you're going to tell me next to a square root. Now I know square root 9, I see an x squared 2 answers, plus or minus 3 in this case. I'm scared of that, even though it's true.
Factor.
I'll factor into what? X subtract 3, x plus 3. Now tell me from day 1 when I first met you, as you entered that door, something we did that I should apply here to finish it up. Sign analysis. Who said sign analysis? No. Now, sign analysis. That means to be very careful. You will place your so-called critical numbers, negative 3 and positive 3, open on the number line. And to save me a little time, you know the next step, you go through and start testing. Guys, do a test. Whew. Right, here goes. You think it's out to the left of negative 3, I could test the number. I'm standing here looking at it. I think out to the left of negative 3 may work. Does it?
Yeah.
Or not? Will this interval work
Yes.
if I test it?
Yes.
In between, I'm looking at maybe trying a 0 here without showing all the work. If I place a 0 in there, 0 subtract 3, that's a negative 3, 0 plus 3 is a positive 3. I don't think that's going to work. Out to the right of 3, maybe try 4, and I think you'll find it to work by sign analysis. Therefore, the answer that we will finally get here, from what Shane gave me, I haven't solved it yet, had better either fall here or here, or I can't use it. And we've got another one to consider. Here, this was easier. X must be what? greater than a negative 3. Is that true? Wow, if x is greater than negative 3, hold on. I don't know whether I should do it, but I think I'm gonna try to do it. Suppose I use a different color and shade to show x is greater than a negative 3 on that same number line. Would that be doing this? All the way down through here. Would that be doing that? Whew. So my answer's got to fall within that, or I can use it. Okay, here goes. Geez, guys, looks like the only thing that I'm really scared of not being able to use is what answer? I'm a negative 3. Okay, try here. Okay, to solve this, here we go. Step 1. This says if you're going to use the property with logs, and these are logs, let's use the quotient property. Let's rewrite this as log base 4. This over this is equal to 3. Did I translate that correctly? Oh boy. Then this could be simplified. Gotta be careful. I think the numerator will factor difference of squares. And over this equals 3. I think this will cancel. I'm just trying to clean it up a little bit. So guys, this actually becomes log base 4 of merely what? X subtract 3? Don't make a mistake here. Equals 3. Yes or no? Now, can someone tell me, because I got to find x. Can anyone tell me what does that look like written as an exponential? What does it mean? Alex.
4 cubed equals.
You gotta know that. This is the same as saying this. The word log is gone. That's what it means. That's what I was doing before the break. Now, this is across the street. This is middle school. This is 64. X subtract 3. Add 3, I think this becomes 67. See if I'm correct. Now, is it? Is it 67?
Yes.
May I use it?
Yes.
Does it fall within all this mess we were talking about up here? The 67 way down here? Is it going to be picked up? Well, let's see if it is. It's 67. Where am I? Where am I? Where am I? The 67 falls either here or here. Is it either or? It does fall here, doesn't it? At the same time, is it greater than negative 3? I can use 67. After all that work, I can use that answer. Whoa. Shane? Class? Is there another one there to solve?
There is.
Let's try one more.
Okay, 2 log base 13,
Whoa. Whoa. Log base 13, okay.
x plus 2
X plus 2.
is equal to log 13,
Base 13.
log base 13, sorry, 4x plus 7.
4x plus 7. Oh, this is very interesting. This might be the last one we'll do tonight. It's all about properties. That's why I brought this in. Does anyone see on the left-hand side, before I jump in and try to find x, can I do something with it that might help me? Is there a property of the 3 properties that I could apply? Could I move the 2 back up here? That's called the power property, which may help me. In fact, I can do it right now. This is log base 13. This becomes x plus 2 squared. The other side, guys, first tell me, look at the right-hand side. May I use the product, quotient, or power property on the right-hand side? No. Nothing. Nothing. You gotta leave it like it is. Cannot split it up. Now tell me, common sense, what has to happen here? For those 2 sides to be equal, what has to happen?
must be equal to what? That.
Is that true? Must those two parts be equal? Now we have the base is already equal. The base what, 13? Must those two other parts be equal if I want the two sides to be equal? That says x plus 2 squared must be equal to 4x plus 7. Log's gone. As I translate this, log's gone. Now I'm in the middle school. I'm gonna suggest, and I think Shane was telling me, I'm gonna go ahead and expand this out, guys. Make this x squared plus 4x plus 4, was it? And this is 4x plus 7. If you guys agree. Is that middle school? It's gonna be a nice little quadratic, so let's move this over. Hold on. If I move that over, will the 4x's cancel? Don't let me make a mistake here. So I got x squared is equal to, and you say, wait, Professor, if I want to solve this from middle school, you might want to move the 4 over here with the 7, subtract, and you end up with what? 3? Yes or no? And then solve for x, what would x have to be the way it looks right now? Plus or minus, because I see a square there. Radical 3, square root 3. True? Now, tell me, may I leave it, turn my paper in, and say, Professor, the answer is plus or minus square root 3? Or is there something else I should do before I turn my paper in? And it better fit the domain. The domain of this one is x plus 2 must be what? X is greater than what? Negative 2? This one says, gotta be careful, 4x plus 7 in terms of the domain must be that. X is greater than negative what? 7 over 4 is it? Oh, the negative 1 3/4. Oh boy, here it goes. Now keep in mind, I got two answers to consider. Let me separate them. Let's see if this one makes sense. Let's test the radical 3, positive radical 3. Is positive radical 3 greater than a negative 2? Because it is positive. Is positive radical 3 also going to be greater than negative 1 3/4?
Yes.
So it looks like radical 3 is good. How about negative radical 3? Is negative radical 3, that's a little tricky. Negative radical 3, is that greater than a negative 2? If it is, I'll accept it. Mr. Park, can you find me a quick approximation for radical 3? I think it's 1.732. See if I'm right. 1.732 is it?
Yeah, 1.732.
Yeah, okay. So is a negative 1.732, is that greater than a negative 2? I think it is. Is also negative 1.732, approximation there, is it greater than a negative 1 3/4? Because I got to satisfy both. It's not?
Wait,
Wait.
why?
Oh, yeah.
is it-
It is greater.
Is it greater than negative 1 3/4?
Yeah.
Yeah, because we what said negative 1.732, something like that. It's greater? If it is, I accept both these answers. Whoa! Now you said, Professor, I see what you're doing. You're putting the restrictions with the domain. If my answers do not fall within those restrictions, I can't use them. I see what you're doing here on the board, Professor. But let me do this. No, that's going to make it even worse. If I actually took them back and plugged them in, look at this. Radical 3 plus 2. You say, what? And I think, were we squaring this after we did that 2 up there? That radical 3 plus 2, you got to square it if you want to actually plug in for a check. Is that true? Maybe a little bit harder to do to check. I think both those answers are good. Looks like a check. You guys agree? Okay. Shane, I think I need to stop, but I think I remember the worksheet. Tell me what's coming up next.
You mean the next
Yeah, the
section
next
or the
equation.
The next equation is ln x plus ln x plus 2 is equal to 4.
Oh, my God. Hold on. Ignacio, this is a nice one to do, guys.
Yes. I have a question.
Go ahead, go ahead.
When we did the logs and we set them equal to each other, could we have moved it to the other side and then do a?
Oh, look at this. Don't say that again. Say it.
Where we set the logs equal to each other, could we have moved one to the other side and then just do the quotient?
He said, Professor, could I have it initially move this term over, made the minus, and therefore since I see a minus sign between the two logs, I can use quotient property, rewrite it as a quotient, brilliant. Brilliant. It would work. It would definitely work. Okay? May have saved us a little bit of time. Okay, Shane, read that last one to me and I'll do it.
It's ln(x).
Okay, hang on now. It's a natural log, it's a base E. Okay.
Plus natural log of x plus 2
Got you.
is equal to 4.
4?
Mm-hmm.
Okay. Yeah, this is my last one. 'Cause I sort of think I remember this problem. Oh, yeah. Guys, suggest to me, with all we've done tonight, how would you start?
X times X plus 2.
Can I use the product property? Because you're adding logs, so could I rewrite this as ln x times x plus 2 is equal to 4? Now here's the issue. That's why I'm having this one be my last one. Product property. Now can someone tell me exponentially, in exponential form, what does this look like? Translate for me. You translate some of these others for me. What does that look like if I ask you please drop the ln? Tell me what it means.
E to the power of 4 equals x times c
Bella?
times 2.
Thank you. Thank you. Thank you. That's what it means. If I see ln called natural logs, it's understood to be a base E. They don't write the base for you. It's understood to be an E. She's translated for me correctly. Guys, there's no ln now to worry about. But what I have to worry about is, how are you going to solve this equation? Well, first, I'm going to write this as x squared plus 2x. Is it true? Now I'm into a middle school problem, a little bit tougher. It's a quadratic. It's going to be a little strange. You got this. If you guys are at the top of your Math 7 class, after all this, I'm going to definitely find you. I'm going to find you. I'll find you in one of those Math 7 classes. And I ask, what are you doing? Why do you get a fail on that last test? You guys agree?
Yeah.
Now, I will tell you ahead of time, I think you probably know quadratics can be solved by completion of the square, quadratic formula, so forth and so on. Factoring, this will not factor. I'm going to use quadratic formula. Get ready. X is equal to, here by quadratic formula, -2 plus minus square root, b squared is 4, subtract 4 times 1 times the negative e to the 4th, for goodness sakes, do not let me mess upon this, all over 2. Let's step back and look at it. Do you guys agree? Did I put everything in correctly? Simplify this further, I better bring it up here. X is equal to -2 plus minus, well, that's last we had tonight. Square root of, guys, underneath here is something strange, but it's there. What is it? What's underneath there?
4 plus 4e.
4 plus, hang on now,
4e.
4e to the, was that a 4 there?
4e
E to the 4th. All over 2. Step back and look at it. Looking good, looking good. Now what?
Simplify the 2.
Do it again.
Simplify the 2.
Alex, that's you?
Yeah, -2 and 2.
Wait, hold on. This is what I see when I score quizzes and exams for you guys. Don't cancel these out now. I know it's tempting. Don't cancel yet. Something also maybe happening here. We'll go cancel those twos out. I know it's tempting. Does anyone see anything to do with that square root of 4 plus 4 e to the 4th? Just simplify it somewhat. Underneath there, what can I do to simplify it? Can I take out a 4? Can I factor out a 4 in those two terms? And make it look like this. All over this. Alex, I'm gonna finally get to what you were saying. -2 plus minus. Now since I have that inside part written like that, guys, what's the square root of 4?
2.
I can bring that out front, leaving this all over this. Yes or no? Well, what do you think the last thing I can do on this one is? Can I now, Alex, here goes, can I now reduce all those down by 2? Or divide by 2? And have x is equal to what? -1 plus minus just 1 square root of that. Wow. I'm supposed to, I'm running out of time here though. I'm supposed to go back and see if they're okay. The restrictions, like we did the others. So guys, you'd have to separate this and have to use the calculator for e's, 2.718. You have to crunch it out on the calculator there. I have not told you which ones work. I think both should work on this one. But before I leave it, a student gave a 2-minute break. And I'm so glad the student brought this to my attention before we start the quiz. I've seen this so many times. And I told you guys I used to teach at Ohio State. I saw it there. I see it here. I might think the square root of 9 plus x squared is, I might think, as a student, it's this. Wouldn't you? Sure thing. Now, may I accept that? No. The thing is, before we learn how to take this quiz, if I saw this in elementary school, which is a true statement, how do I know that's true? Because if I square that, 5, I get that. If you square this, you will not get this. If you square 3 plus x for a little check here, I think 3 plus x when you square it is what? 9 plus what? 6x plus x squared. No, I cannot. And therefore, the reason I did that to close down tonight, you might think on this one, oh, professor, it's the perfect square root. It's 1 plus e squared. It's not. You can't do it. Got to leave the answers like that. Guys, wonderful class tonight. Chapter 4 basically is done.